Hello everyone, my name is Socheata Hour. Over the summer, I work in Dr. Stefano Carpin laboratory at UC Merced. My project is to use ROS2 Foxy to develop a robot high pressure chamber of the OMRON TM5 900. The OMRON robot is one example of a high-performing robot that can perform a precision task. As the user can input more data that yields a better result, overall automation is increasingly important in various of sectors, where it can minimize repetitive and dangerous work for humans. However, the robot arm are normally automated with simple tasks, so there is challenge when we want to integrate an opening robot system for a complex task. In Dr. Stefano Carpin Lab, I explore this challenge by using ROS2 Foxy. Since it is a new operating system, there is lack of learning resource. Moreover, it is my first time learning and understanding the network connection between the program and the actual robots. Next, for the technical contribution, I use ROS2 to launch robot in 2 simulators. The gazebo provides an environment that mimics the real world, while AVIS2 is for robot motion planning. Over the course, I able to successfully spawn the robots in the simulators that allow me to visualize a graph that explains the network connection between the system. I also able to experiment documented ROS2 for the future use in the lab. Since this summer is quite short, I'm not be able to complete all my tasks. So my next step is that I want to visualize this OMRON robot on top of the Husky, and then I want to create a Python code that allow me to move the joints in the actual robots. This summer program allow me to see myself in a bigger picture, that I want to continue to do research in robots where I can apply AI science together to create a robust robot for the future. Lastly, I would like to acknowledge Dr. Stefano Carpin, graduate students, fellow intern, and the CITRIS Workforce Program for this summer opportunity as great as possible. Thank you very much for listening.
Hi, my name is Amrita Mohandas, and I am a fourth-year computer science and engineering major at UC Merced, where I worked with Castro Lab in order to solve the problem of teleoperation of an F-110 robot. The aim of this internship was to develop a system for remotely operating an F-110 racing vehicle, and such a system could be used to demonstrate how much of a delay in the transmission of data between the robot and the remote computer can impact the possibility for accidents when trying to remotely operate real-world road vehicles. The start of my internship was mainly focused on learning about ROS, or Robot Operating System, which is a software framework with lots of libraries and dependencies that allow for different components of a robot to communicate with each other simultaneously. Using the robot's LiDAR sensor and odometer, I was able to develop an algorithm for automatic emergency braking, which was an essential first step in preventing the robot from incurring any damages when testing algorithms in the future. And using existing ROS libraries and dependencies, I was able to develop a connection between the F-110 and a remote computer in order to send and receive sensor data and joystick commands between the computers, and also send live data and stream it to the remote computer from the robot's camera for ease of teleoperation. Here is the system working as a whole, and on the right, you can see the perspective of someone operating the car from a remote computer using a joystick and using the video streamed from the robot to the remote computer. In the future, we hope to test and collect data on how delays in the video transmission and operation commands can impact the potential for accidents and potentially expand the teleoperation system further. And in this internship, I learned a lot about active listening and learning and the importance of documentation when it comes to preventing problems from occurring again and again within a project. I also learned a lot about problem solving as an individual and within a team. And here are the people I would like to acknowledge for making this internship such a memorable experience and for making it a very informative experience as well. Thank you.
Hello, my name is Aditya Purli and I was part of the CITRIS Innovation Program, who has been paired up with OMRON Labs, a robotics startup company based in San Francisco, California. As a software engineer, I worked on projects involving UI design and machine learning algorithm. In my first project, I helped create a UI design controller for a robotics arm project. This was very important because the company needed to show investors of a working product to get funding. I used languages such as HTML, CSS, JavaScript to help build a prototype. The controller will be used from the computer to control the robot in real life. It can be programmed to do tasks such as welding, picking up items, placing items, painting, and packaging. The image on the left is the UI design I was implementing. In my time working for the second project, it was very limited because it was very advanced. I mainly used Python and PyTorch to help debug and fix errors. I also read a lot of research papers on different machine learning algorithms to help my team find one that would reduce gear transmission error. The image on the right shows the problem that was happening when the gear has a gap between the axles, which is causing a small error. We created multiple models and the team is still currently trying to improve the model before releasing the product. Currently, the product can be only pre-ordered. I had a couple challenges during the internship. Coding in the real-world environment is very different than university classes. In university, we have test cases to make sure our code works, but in the real world, there's no test cases. So we had to make our own simulations. Also, learning the knowledge necessary to complete the task took a while because it was completely new things I have not experienced or learned in university. In the real world, everyone is in different time zones. So meeting with the teams in India, I would have to take meetings at 9 p.m. Pacific Standard Time Zone. Time management was a big issue for me since I'm taking multiple classes and doing other things on the side while maintaining a full-time job. I would like to say the experience was great and I learned a lot about how the future of my career is going to be. As my internship comes to an end, a few improvements left to do is the UI design side of things is to make the design colorful and make the sliders smooth. In regards to the machine learning project, the next step is to do research and fine-tune the algorithm to get the least amount of error. For future people taking over, there is documentation from Figma designs and GitLab history logs. Lastly, I would like to thank the CITRIS Innovation Program, my mentor Nicole Cotton from the CITRIS Innovation Program, Satish AV, Aditya Bhatia from Orangewood Labs for this great opportunity. I've learned a lot from this opportunity and thank you guys for listening to my presentation.
Hi, this is Russo from UC Davis. During this summer, I have interned as a mechanical design engineer at CITRIS Robotics, where my job was to design surface exploration rover for Moon. So the main problem I did during this internship was to design an exploration rover for Moon, which can share the data from the Moon surface to the ground team, so that the team can explore the human existence on the Moon. As a part of Artemis program, NASA was planning to send rovers to explore the Moon, in which CITRIS Robotics, the company I was interning, was one of the companies selected to partner with NASA. So the basic technical contribution I have given during this internship was to do rover sizing based on project requirements, like to climb a rock of 30 centimeters or traverse a slope of around 30 degrees. Uh, so as you can see in the figure, the rover was designed to climb a height of a rock of height 30 centimeters and angle. Using these geometric constraints, we have given basic sizing of rover. And the next part, second part of my internship was to deal with wheel design, where I have designed the thermal part of the wheel and also the grouser design, motor and gear selection, modeling in SolidWorks, and static stress analysis in ANSYS. The major learning from this internship was to develop skills like analytical skills, brainstorming, modeling, and analysis skills. Also, I have developed my documentation skills. Uh, this project can be further extended by conducting thermal analysis of the wheel using ANSYS for the radiation on the moon, and the axial design for the wheels has to be done. Uh, Further, the model can be 3D printed and tested, and with these results, the design can be further improved for uh, for uh, for exploring the moon. So the major reflection during this internship was to understand my problem solving and analytical skills, and also space industry being a cutting edge technology and a zero failure system. I was able to realize like how different scenarios can be interpreted to avoid the failures in the space industry. Thank you.
Hello, my name is Karen Tapia, and I'm a UC Berkeley mechanical engineering student. And this summer, I had the pleasure through the CITRIS OMRON TM5 program and the Workforce Innovation Program be partnered with Silicon Valley Robotics to work on a project called A Guide to Robotic Research Labs and University Courses in the Greater Bay Area. The big picture for this project was we wanted to create a report / catalog to showcase the various robotic research labs and related courses in the Bay Area. We also were able to include the demographic information, STEM economics, and different opportunities that community colleges offer in STEM. The big motivational factor for this project was we wanted to help high school students, undergraduate students, and graduate level students stay aware of the possible research opportunities and courses that are out there. We also hope that this report can also be sort of a connection / collaboration point between universities, robot research labs, and industry partners. The problem that led us to this project was that there's a lot of groundbreaking research being conducted, but it's all found through universities. So we wanted to create a place where all these research opportunities could be showcased. One of the case studies that was included is Dr. David Quintero's research lab, the Control for Assistive and Rehabilitation Robotics, the CARE Lab at San Francisco State University, where he works on prosthetics and exoskeletons. Some of the challenges through the internship was finding all the information about the labs and courses, and also what helped was looking at different reports that already exist and seeing what information should be included in this report. There was a lot of data collection, proper research, lots of communication and outreach to different professors. In the end, I was able to get around 13 to 14 professors to participate. A lot of the skills learned in the internship were different forms of proper communication, planning, prioritizing, multitasking, and problem solving. In the big picture, I was able to learn a lot about the different robotics research that's being developed and the technology that's being conducted, the technology that's being created. Next steps, we hope that this report will be updated yearly, and we hope that there's more participation from different professors so that the resource can be a greater use. Overall, the internship was very valuable and very positive, and I would like to thank Andrea Key, my mentor at Silicon Valley Robotics, for all the help she gave me this summer, and also I would like to thank the professors who participated in the report, and the CITRIS Workforce Institute and the Workforce for Innovation Program for all the workshops and that prepared me for this internship. Thank you so much.
My name is Anthony A. Russo. I am a CITRIS Workforce Innovation Program summer intern and a rising senior studying computer engineering at UC Santa Cruz. This summer, I worked on a project known internally as the AI Economist for Apprenticeship Learning at the Tech for Good Lab at UCSC. The fundamental question at the heart of this research project is, how can we better understand academia? Apprenticeship learning opportunities are some of the most effective engines driving education and research throughout academia and industry. However, such opportunities have the potential to be both more common and more impactful. Building off the work done by Salesforce Research, the AI economists, this research project aims to utilize multi-agent reinforcement learning techniques to research apprenticeship learning dynamics. The goal of this project is to provide a mechanism to inform policymaking for universities and private companies to bolster their apprenticeship learning opportunities. As an intern, I primarily encountered challenges of two types. First, this research project required a strong understanding of real-life apprenticeship learning environments, particularly in academia. My advisor, Dr. Lee, was able to provide insights into how various mechanisms of school-sponsored internships and student research work. Some conceptual questions I had at the start of this internship included, what happens if a mentor cannot find any mentees to join the research project within an acceptable amount of time? What becomes of the project then? To what extent do mentees value education or increasing their own skill as compared to immediate payment? Second, creating a simulation to model this complex environment required a good amount of reading, especially as I had no prior experience in machine learning. Most of my technical challenges were overcome with patience and testing. As an example, in machine learning, having more variables you wish to account for entails for a longer training time for the model. To keep runtimes manageable, a balance had to be struck between making the simulation realistic and limiting what was represented. During my internship, I was able to complete the single agent scenario, which allows students and professors in the simulation to only work on projects individually. However, this work provides much of the functionality required for the upcoming multi-agent and planner scenarios, which will see agents working together and finally, under the management of a planner organization. Next steps. I have agreed to continue to work with the lab as the project lead going forward, which means I have a few tasks ahead of me. First, I will need to fully flesh out the project's documentation, most of which has already been completed. Second, I will need to train new team members, one of whom has already joined me and we are continuing to onboard him. Third, the team and I will need to complete the multi-agent and planner scenarios as previously described. And finally, as a research team, we hope to publish a research paper under Dr. Lee's advising before the end of the coming school year. And last, I'd like to acknowledge Dr. Lee and give him
Hello, my name is Kaisin Yu, and I'm attending UC Santa Cruz as a fourth year majoring in robotics engineering. Thanks to the CITRIS Workforce Innovation Program and its team, I was able to obtain an internship at Orangewood Labs and be responsible for the market research and competitive analysis during this program. To better understand what I did throughout this internship, I'm here to present the big picture motivation and problem I was dealing with during this internship. So I needed to study the market scenario of the company, predict market demands and supplies, as well as understanding the technical characteristics of the company product, which is a robotics arm shown in the picture in the right side of this slide. The technical contribution and learning I was able to provide and gain from this internship were to conduct research to find data and provide answers to my supervisor questions and added data to our system, determine the appropriate ways of collecting data in collaboration with the team, and finally develop, update, and put into practice research methods and procedures that work best for me and the team. The next steps and my personal reflections from this internship experience are to be able to become more aware of the client's request of the topic research, which in this internship were the research topics that my supervisor was providing me during the internship, and I needed to collect data and research about as well as analyzing them. The second improvement and takeaway from this experience was to improve the data organization and analysis so people can better understand the data I collected when they were reading it. Last but not least, I want to thank you the CITRIS program and its team, as well as the company Orange Fruit Labs and the team I work with, as well as the people I work with for making this opportunity possible. This is the end of my presentation. Thank you for listening.
Hi, my name is Cherilyn Yu. I am a sophomore at UC Berkeley, and I interned under the Silicon Valley Robotics company in the IEEE Robotics and Automation Society. So our big picture motivation and problem was that a lot of robotics companies around the world were very disconnected. A lot of them are not really active within their sector of robotics. So the goal of the IEEE RAS is essentially to connect robotic companies to foster creativity, community, and innovation, as well as collaboration. So we also wanted to help keep these organizations updated and active within their respective sectors so that they could attend conferences that were related to their company, or they could see other companies' innovations at the time with case studies. We also worked to essentially collect all of their personal information so they could contact each other with their email or their phone, or reach out to a person or representative of a different company. Our technical and contribution and learning. So my main job was first to create a huge Google Sheet to compile information on all the robotics companies in the world. So on the right, you can see that there's a huge Google Sheet, and in it, it has the date, the street address. It also has their website. It has the amount of money they raised, and as they also have like their category or their sector, whether that's healthcare, agriculture, or it could be artificial intelligence. We have a lot of different sectors, and we organize information for each of those sectors. Another thing that I did was I created a summary sheet for the IEEE RAS website, specifically on health and medical subsections of robotics. So in this, I wrote about upcoming conferences, current news articles. I also described what the health and medical page was for newcomers. And finally, I wrote to companies to request prototype descriptions and context of their main products. So this was for our case studies to allow other robotics companies to see what other companies are doing. So I had to email the company representative to request their prototype descriptions and to kind of see how they were improving on their product. And finally, the next steps and personal reflection. So I'll continue to edit the webpage for the IEEE RAS Health and Medical website until published. So you can see on the right is a case study on a company called Seismic Powdered Clothing.
Hello, my name is AJ, and I'm a sophomore at UC Santa Cruz, and this summer I worked on PDMS chip mold design for Unique Lab in UC Santa Cruz. So the first question I need to answer is what challenges did I have and what problems did we aim to solve? So as far as our lab goes, we definitely needed constant PDMS chips for the various experiments that we were running, and ultimately it's very expensive to keep buying new chips, so it becomes easier to make it yourself. But to be able to do this, you do need to make molds for the chips to be printed in, and that was my primary job this summer. It was to make these molds and help the lab so we could run more efficiently. As far as what we used to make these chip molds, the platform I used was Autodesk Fusion 360. And since the demand for these chips was so high, I did have to create quite a few and create them quite often. I put two on the screen that I created. So these are two unique designs. And I think the biggest lesson I learned from this was how I was able to use my old designs to improve my future ones and also take aspects of the old ones in order to create the new ones faster. So my reflection on the future is that I do hope to explore the hardware aspect of chip design, because I kind of did the mechanical because I was designing them. and I do hope to continue work with semiconductors in the future. I'm an electrical engineering major, so this is probably something I'm going to come across again. And I do want to learn more about chips because I also live in the Silicon Valley, so it's the home of semiconductors. Lastly, I do want to thank Professor Yannick for the unique opportunity to work in his lab and graduate student Ray Jara for allowing me the opportunity to help him with these chip designs and also guiding me along the way.
Hello, my name is Maximo Zendejas. I'm a student at UC Merced. Over the summer, I worked at a place called Carpin Labs at UC Merced on the project called CO2 sensor automation. So starting my internship, the CO2 sensor was already made. It's simply a device that's able to monitor the CO2 concentration in fields, especially agricultural fields. The purpose of making the sensor was the idea that if we were able to monitor the CO2 concentration in a bunch of fields and create new ways that the fields would be able to absorb the CO2 from the atmosphere and place it into the ground. By doing this, we'd hopefully be able to reduce some climate change by no longer having as much CO2 in the air, and it would be in the ground. My job was simply to automate the data entry process. So instead of having a regular person go out to a field and monitor the CO2 concentration levels, it would be a rover. So the college already provided me a rover and a motor, and here are the 3D models right here. My job was simply to make a mount that would attach the sensor to the motor and the motor to the rover. And by having this, we would be able to automate this process instead of a person doing it. It would be a robot that would be pre-programmed to go to selected destinations, drive there, lower the sensor, analyze the data, raise it back up, and then keep doing it for the rest. So after the design was made, I made a parts list. The parts were looked at, and then the parts were ordered. When the parts arrived back, I was able to physically make the motor, and this is what it looks like right here. So next steps would be to simply reduce the price of this mount. So reducing the pieces, reducing the cost, and hopefully making it easier to build next time. The idea for this would be to have multiple rovers with a CO2 sensor attached to it, so that we'd be able to vastly improve our data entry. Instead of just having one motor, we'd have multiple rovers. Special thanks to Stefano Carpin, my manager, who guided me through this and who gave me this design and who provided me with the things I would need, and to CITRIS for giving me this opportunity to work on this project.
Hi everyone, my name is Wendy Chen, and I'm a third at UC Santa Cruz majoring in computer science game design. And this summer I interned at Yannick Lab, where my internship was around making photolithography mass designs and 3D visualizations of chips in AutoCAD. And the focus of my internship was around the most economical way to fabricate a chip. And so I created mass designs for fabrication shown on the right here. And then these designs would be used for biosensing projects or for designing lab-on-chip systems. And so my technical contributions was making those mass designs, which involved learning CG, part of ImageJ, and image processing software to help get the measurements of the chips. And right here, I measured the diameter. When the first length, it was given in pixels. And then since I knew the distance was 1 millimeter, I could set the scale based on that to set the length. And so I got 1 millimeter the second time I measured it. And using the scale, I can measure other parts of the chip, like this diameter, which I got 3 millimeters, and to just get the other dimensions of the chips for making the designs. I also had some time to work on 3D models of different objects, like interdigitated electrode sensor chip shown on the left, and also an experimental setup where we pipetted solution into a reservoir. And then using an electrical field, we can accumulate polarized particles on the chip to detect proteins and bioparticles. And then these models also help show figures in a presentable way, which will be used in manuscripts. And application of project was that our group used DMOS to actually fabricate the chips shown on the right here. These were the chips after they were fabricated in the silicon wafer. And during the fabrication process, you selectively expose certain regions that you want to fabricate on the wafer. And then when the UV light shines on the surface, the areas that are interacting with the light will go away. And then it leaves this in the end. These chips will be taken out individually to be tested on and used to design biosensors, point of care diagnostic chips, or lab on chip systems. And for future designs, I'd also be able to create any type of mass design and models in AutoCAD. So I want to thank Professor Yannick for having me this summer and my supervisor, Ricky Passon, for all of the guidance and helping me when I had questions and really just allowing me to learn so many new skills this summer and have a really great experience.
My name is Carl Vincent Cuyos. I am a fourth-year robotics engineering student at the University of California, Santa Cruz. And this summer, I interned for the Autonomous Systems Lab under Professor Gabriel Alkheim. The big picture, motivation, and problem that I tackled this summer is that the current visualization of the vehicle display found within the UAV feedback control system's Python script was not able to render smoothly and in real time. In addition, the reliability of this visualization tool was limited to the user's perspective and their understanding of the programming itself. So the objective was to find a method that can optimize this vehicle display and create a prototype for visualizing the control system found within the UAV feedback control system simulation. The technical contribution and learning that I did this summer was that I created a method to execute parallel simulation using pseudo-Z buffering to improve graphics rendering efficiency by 80%. I also designed multiple iterations of a miniaturized RC plane using SolidWorks. I also received feedback from mentors and colleagues about the optimization and visualization tasks throughout the internship duration. And lastly, but not the least, I successfully controlled each servo on the prototype RC plane to validate the proof of concept that I made, as seen at the right. This is the simulation before the optimization patches that, as you can see, the plots were not rendering very smoothly and very slowly, as well as the vehicle display. And afterwards, with the visualization patches, you can see that all the plots are rendering in real time, as well as the vehicle display. Here's some engineering sketches and brainstorming that I did for this internship. You can see my notes about the RC plane, some renditions, and some even discussions of how to assemble the RC plane itself that I discussed with my mentor. Here's my starting prototype design with very unpolished ideas. And lastly, my final prototype design with a little bit more better assembly of the control surfaces and its RC servos. The next steps in personal reflection that I did with this internship is that I want to be able to feed data to the RC plane servo system to manipulate control surfaces by applying my knowledge of embedded systems programming. I want to understand more about control feedback systems so that I can improve on the feedback control system that is existent and create an attitude estimation algorithm in the Python script, as you can see at the right. And lastly, but not the least, I also want to improve the current RC plane prototype by finding ways to manufacture it for class use and even publicizing it. Special acknowledgement and special thanks to Gabriel Alkheim, Carlos Espinosa, Young Wang, and most importantly, the organizers and leads for the CITRIS program for making this event happen.